Good afternoon, this is Schweitzer, and this is a quick little video on what's called reaction mix 1. Now, this is getting towards the end of our chapter here, and this is kind of where we start putting everything together. And sometimes kids have a little issue with just kind of getting started on this, and this is some of the things that I might do for students just to kind of get going on this. And once you get a handle on this, the test itself, you should be pretty much ready to roll on this final exam test. Alright, so first things first, we have located here our basic templates. And some kids choose, if we have a note card, to put this on their note card. I've seen kids cut this out and put it on a note card. But ultimately, you should be aware of just kind of how it looks. Here, for example, we have something that has no charge. Typically, it's a solid or a pure liquid or a gas. And we have an aqueous solution. And we'll have a lab like this too, actually. And then, of course, it exchanges charge. But we have a single individual and an ionic compound. Here we have two aqueous compounds, both ionic, and of course they are mixed together. Putting two things together, two single individuals, one person or one item breaking apart. Neutralization, very similar to this one right here, but it forms water, liquid water. That's how we recognize that. You should also be recognizing an acid when you see one. But acids don't necessarily have to be looking just like this in a neutralization reaction. So those can vary some. But either way, if you see water, it's a neutralization. And combustion also is very recognizable. So one of the things I might do for students, just kind of as we get started on this in class, is just go ahead and write down some of the types of reactions. We shouldn't necessarily, once we have the types, shouldn't be struggling too much with doing the actual reactions. So reaction type here. Okay, so notice for decomposition type, a little note here. But either way, two individual items, okay, just put them together. So this is going to be a composition reaction or synthesis. All right, so I'm going to just do 5 of these here and just kind of set you up here. Alright, so, and I'll just do the reactions types first, and then we'll come back and fill in some work. Alright, acetic acid. Okay, so first things first, we got to write out this is H. Alright, C2H3O2. This is an oxyacid. And an OH. Okay, so note we have a cation here on the acid. Acids have a cation, and we have an anion. Alright, and then we have +1 and -1. So here, this is a situation where it looks very similar to our solubility. So I might write down solubility or neutralization. And I know it has an acid in there, but we'll pick one of those two when we get an answer. If I get water, I'll put neutralization. Alright, here we have another, well, looks like an acid. But either we have a cation and we have an anion, -2. That's why that 2 is there. And we have a +1 and a -1. Okay, so again, solubility or neutralization. It's up to, when we get our answer, we'll see which one it turns out to be. Here, two individual items, just going to put them together, composition or synthesis. And the final one here, we'll do 6 here. So this is going to be a single individual, no charge. Right off the bat, it cannot be solubility. Okay, this is going to be changing charges. We have +1, -1. This is a redox reaction. Okay. And the last one here is 6. We only have one item, and it's going to break apart. So decomposition. So in this one, I'm just going to predict the products on these guys, and I will give some hints as to what you got to do to finish them off. But I'm not going to do them from start to finish. If you likely could have a answer key here to check your answers. But this is just to get you started. So first things first, put these two things together. So H and O. Alright, put those together. In the elemental form, they're diatomic. But here, mixed two together, it's going to be +1, -2 charge balance, and I get H2O. That's fine. I mean, putting things together, you're not necessarily going to know what they're going to do, but that's typically what we would do. And then we balance it. Next one. Okay, so we're going to write this out, the potential just swapping cations and anions. So H and the OH go together, and this is going to be liquid water right away. That's a common mistake. This is a neutralization reaction. And I get Na and the acetate together. NaC2H3O2. This is a +1 and a -1. Okay, so that's charge balance. And because I have a quick check solubility guide, this is going to be aqueous. It doesn't have to be aqueous. It could be solid. In this case, it is aqueous. All right, here we go. H and okay, CO3, H, all right, and CO3. Got +1, -2, so I'm going to charge balance this to 2 right there. And then I have K and the dichromate. All right, K. All right, and then we're going to go Cr2O7 +1 -2, and there's a 2 here. This is not forming water, so we're going to call it a solubility reaction. You would check the solubilities of these two guys right here. And I'm not going to go through the solubility checking of that solubility chart. You can look that up if you'd like, but that's what I would do to verify that. All right, 2 individual items, let's put them together. Zinc and sulfide. Metal, non-metal, that's an ionic compound, so charge or balance it. This is +2, -2, and therefore, there we go, composition. It actually also is a form of a redox reaction. So I would also accept redox reaction for this guy because we are changing charges, as you can see, across this reaction. Same thing for that guy. Technically, it is a redox reaction. Anytime you have charges changing from 0 and 0 to +1 and -2, that's a redox reaction. All right, so here, again, we have our metals and metals. Metals exchanging with metals. So the silver will be taking its only charge, which is other charge, which is going to be 0. And the aluminum can only take its only charge, which is going to be a +3. That's the exchange of electrons. And then the nitrate is a spectator ion. Of course, this is a molecular equation, which isn't showing everything, but this is a common way we do it. Balancing-wise, pretty simple, just to put a 3 here and a 3 here. You would need to check voltages on this guy. I'm not going to go over all that, but you would need a net voltage on this guy to know if it's positive or if it's negative. And that, in that sense, we would be able to tell, is it going to run or is it not going to run? Other ones I would mention a reminder that in this situation here, if you get 2 aqueuses, then again, technically nothing's changed and it's a no reaction. No reaction. Here, if I get a negative voltage, that is a no reaction. Alright, decompose just says here decompose to elements. Okay, so the standard element for nitrogen is N2, and the standard element for hydrogen is H2. And in this case, you'll note that, just so you know, this is a +1 oxygen state. This would therefore be a -3. This is 0 and 0. So even though it's a decomposition reaction, it's also a form of a redox reaction. And we would balance it. It would balance nicely. Put a 2 here and a 3 here. All right, so this is a head start on determining this overall picking out reactions and solving them out. Thank you very much.